And we're on to Unit 10, Transformations. Section 1 is all about translations and reflections. So those are two different kinds of transformations. Transformations are basically just any time you take a figure, a shape, or just something you see and it changes. So we're going to go over some terminology. Very first thing here, we've got image. Now the image is the new figure after a transformation. So if we had like a triangle, and all of a sudden we made a new triangle, the new triangle is called the image. The pre-image then is the original figure before that transformation happened. So the pre-image will wait for either a translation or a reflection to happen, and then the new thing, the new figure that we see, is called its image. Now for notation, we would say things like A, B, and C are original points. So if I have just a random point sitting here, I would call this point A. Now if all of a sudden it changed and somehow it moved over here, we would call this point A prime. And it has that little kind of apostrophe at the end of it. So when there's that little dash mark there, that's called prime, and it means this was the new piece. So this was our original point, and then it moved over here, and we now call it A prime. So A, in this case, would be a pre-image. A prime is the image then. So if we had more, let's say A, B, and C, so we make an actual triangle, A to B to C, A prime to B prime to C prime, would look something like this. ABC is the pre-image, A prime, B prime, C prime is the image then. So we'd have to put the tick marks on each one. That would be the notation. That's how we say original and new figures. Now, line of symmetry is one way to change certain figures, or one way you can see how figures kind of reflect over themselves. A line of symmetry is just its mirror line. Now, different figures will have differing amounts of symmetry. So like this one, this kind of arrow just has the one line of symmetry. It makes a mirror right here where every point would just reflect right over it. Same thing, all of these points, all of these lines reflect over this red line, makes one line of symmetry. Now this diamond, I guess we'd call it a rhombus, has two lines of symmetry, here and here. Because if you were to reflect vertically, right here, everything can just flip right over it. But we can also cut horizontally right here. All of these lines flip over this way. Some will even have up to 3. We can see this equilateral triangle has 3 lines of symmetry. And there are some figures that would have an infinite amount. So if we have a circle, something like this, there's technically an infinite amount of lines. So I'm going to go like this. Here, everything flips over. Here, everything flips over. Here, everything flips over. Here, you can draw an infinite amount of lines as long as they all go through the center. They would all be reflection lines or lines of symmetry. So a circle technically would have an infinite amount of symmetry. Now, symmetry comes from a certain line of reflection. So a reflection is basically just a symmetrical figure. If we have our line right here, now to find a reflection, we'd say the pre-image is flipped perpendicularly over the reflection line to make the image. So we have B, our regular one. To get to B prime, we would flip it perpendicularly over this line. So we'd have to draw, one way you can think of this is drawing a line that's perpendicular. So these make a right angle. This side has to be just as long as this side. And that's how we would find B prime then. So this was just reflected over that line. Same thing with A all the way over to A prime, C all the way to C prime. They were reflected or flipped perpendicularly over this line, the green line of reflection, to find the new points. Again, you can just kind of think of this line here as a mirror. If you put this mirror here, you can see it flipped the same distance away in exactly the opposite direction here. So for our example, we would call this a reflection over the line x equals 4, because this red line goes vertically right here, crosses at 4, so this line is x equals 4. Now if we were going to reflect all of these points, J being right here at 5, 5, as we reflect it over, it has to go perpendicular to this red line, and it's one space away, so we would put J prime right here at 3, 5. Same thing with M. It is 1, 2, 3 spaces away in a perpendicular line here. So 1, 2, 3 spaces away over here would be how to find M prime. K is 1, 2, 3 spaces away. So again, 1, 2, 3. That'll help us find our K prime. And if we were to connect those then, that is our reflection over that line. So now J prime, K prime, and M prime create our image of J, K, M. And we found it using a reflection. Now, there are a couple of special reflections that we can work with. If we are reflecting over the x-axis, remember the x-axis is this line right here. It's the horizontal axis. If we are going to reflect over that, and we know where our points are at, so like D is at -6, 3. H is at -4, 5. M is at -3, 1. There's a certain rule we can use, and I want you to write down this rule. T, meaning we're about to do a transformation. The original was at xy. That's what we call our points. They're always xy. Now it becomes T prime. So this means that the image then would become, well, the x stays the same. All of these x values are still going to be the exact same. But whatever was your y value is now negative y. So take this y value and just make it negative. That's how you would change it. So I'm going to do M prime using our old method of going from here to this line perpendicular. It's just one space away. So M prime is going to be right here. And we can see that that's at -1, 2, 3, -1. So M prime is at -3, -1. Now that actually fits our rule. The -3 was the same. This 1 from before became negative, so -1. So instead of doing that with D and H, I'm just going to use our rule and say that D prime should be at -6, -3. Because this 3 was positive, it should be negative now. This H should be at -4, -5. And we'll check and see if those do actually make reflection. So if I go to -4 and down 1, 2, 3, 4, 5, right here should be H prime, according to our rule over here. And if I go to -6 down -1, 2, 3, that should be D prime, and these should make our new triangle. And that does actually make the reflection. So here is our line. We can see we just reflected right over that line to create our new pieces. So this is the rule anytime you want to reflect over the x-axis. Just take whatever points you have. The x1 stays the same. The y1, it's the opposite of what it used to be. If it was negative, it's now positive. If it was positive, it's now negative. If we're reflecting over the y-axis, that's going to be the other one, at the vertical axis here. If you want to reflect over that, the rule is going to be take your xy's from before, and now your x is going to be negative, your y stays the same. So first we're going to try it out with M. It is 1, 2, 3 spaces away, so we go 1, 2, 3, the exact opposite direction, and this would find M prime. So we'd say M prime, it looks like it's 3 over and 1 up. And that does actually, again, fit our rule. It used to be -3, 1. We did negative of that, or the opposite of that. So a negative would be a +3. So +3, 1, which is actually where we got. So let's try it with our other pieces then. The x piece, the sign gets flipped, so it's no longer negative, it's a positive, and the y stays the same. Same thing, -4 becomes +4, and the y becomes, or it just stays, as 5. So let's check and make sure those work. 4 up 5, that should be my new H. So call that h prime, and 6 up 3, that would be my new d prime. Connect my points, and sure enough, this image, the h prime, d prime, m prime, this is the image of the pre-image HMD after it was reflected over this line. We can see it reflects over that line exactly. The rule for the line y equals x. Now that line y equals x is this one. Everywhere on this line, if you plug in a y value, you'll get the x value. Or if you plug in an x value, you get the y value. So if I plug in 4, I'm up at 4. If I plug in 7, I'm up at 7. If I plug in -4, I'm down at -4. So everywhere on this line, y equals x. Now if you want to find how to reflect over this line, you basically just flip your x and your y value. So your t of xy now becomes t prime of yx. So basically, all of these would just flip. So d prime would now become 3, -6. H prime would now become 5 and -4. M prime would now become 1 and -3. So let's plot those points out. 1 and -3, right here is my M prime. We'll go 5 and -4. And we'll go 3 and -6. This one was D prime. This one was H prime. And if we connect those, sure enough, you can see how that is a reflection over this line. Here was our pre-image, the original figure. Here is the image, that new figure created after our reflection. And our last one of these special lines, we have y equals -x. Now this one, am I at the right spot? Right here. This one's going to go like this. It's very close to y equals x. It's just the exact opposite. This one is going downwards, kind of a slashing diagonal going down through the center 0, 0. So whatever x value you plug in, you get out that thing, but negative as your y. So 4 would be at -4. 7, we're at -7. -4 would be up at +4, and so on. That creates this line here. So if we wanted to find our image then, after we reflected over that, not only do you switch your two pieces around, you also make them negative. So your y is now in the x spot, and it is negative. Your x is now in your y spot, and it is negative. So for D, if we had -6, 3, the 3 would come over here, but it would be negative. If -6 was in our x spot, it would come over to the y and become positive. So we'd have a +6 here. Same thing. You switch the two and change the sign. Switch the two, change the sign. There we go. So those would be our new pieces then. So let's check and make sure those actually look correct. We'll do M prime was at -1 up 3. M prime. D prime was at -3 and up 6. And H prime was at -5 and up 4. And yes, it does look like this is, in fact, just a perfect reflection over that red line. The whole thing just switches around, and that would now be our reflection given these points. So we looked over reflections. Now we're going to look at translations. For a translation, the pre-image just slides up or down and left or right a certain amount of units. So the rule, you would say, is you take your image, or should I say your pre-image, and to get the image, you just add some to the x and add some to the y. Now, if what you're adding is negative, that would mean if you have a negative right here, you're going left. If you have a negative right here, you're going down. If this is positive, we're going right. If this is positive, we're going up. So this is your your left and right. This is your up and down. So for example, if we need to translate this figure 5 units to the right and 3 units down, so we need to write the rules and the coordinates. Well, for our rule, we always start with t of x and y. And it's going to become t prime of. If we want it to go 5 units to the right, well, left and right, that's on our x-axis, and we want to move to the right this way, which means our x is getting bigger, so x plus 5 would be our rule. If we want to go 3 units down, so we'd be moving downward on the y-axis, we're getting smaller, so y minus 3. That would be our rule. Okay, now I'm going to find b just by moving it 5 to the right, 1, 2, 3, 4, 5, and 3 down. 1, 2, 3. So b prime should be right there, meaning that it's at 3, 1. And I found that by taking the point and actually sliding it over and moving it down. But we can also see negative 2 plus 5 is 3, so it fit that rule. 4 minus 3 is 1, so it fit the rule. So we can just fit all of these into the rule. Negative 6 plus 5 is negative 1. 4 minus 3 is 1. So L prime should be at negative 1, 1, right here. If we start with negative 3 and add 5, we would get 2. If we start with 7 and minus 3, we get 4. So x prime should be at 2, 4. And if we start with negative 7, add 5, we'd be at negative 2. 7 minus 3, we'd be at 4. So p prime should be at negative 2, 4. It's actually right on top of b there. And these ones connected make our new image. And we can see the whole thing was just slid 5 to the right and then 3 down. So if we need to use a rule like this to translate it or slide it, we would literally just plug in whatever we had here, subtract it or add it accordingly, and that's how we'd find our new pieces, and then we can draw it in there. So if we take negative 6 and we subtract 3, we'd be at negative 9 for our x value. If we took negative 2 and we added 2, we'd be at 0. So we're just using this rule. T of xy becomes t prime x minus 3, y plus 2. You literally just subtract 3 from your x value, add 2 to your y value. So subtracting 3 from negative 2, we'd get negative 5. Adding 2 to our 0 here, we would get 2. Subtract 3 from negative 3, we get negative 6. Add 2 to negative 4, we get negative 2. Subtract 3 from negative 5, we get negative 8. Add 2 to negative 5, we would get negative 3. So now we have found all of our points. So essentially what they're saying here is we're moving left 3 and up 2. Let's see if all of those did that. Going from U, if we went left 3, 1, 2, 3, and up 2, 1, 2, that would put us at negative 5, 2, which is exactly what we had here. So this would be our U prime. From our W, if we went left 3 and up 2, 1, 2, 3, 1, 2, put us over here, which is exactly what we have here, negative 9, 0. So that one is done. If we start from Y and go left 3, 1, 2, 3, up 1, 2, puts us right there, right where W was. And for P, we'd go left 3, 1, 2, 3, and up 2, 1, 2. And that lands us right there. So this would be the new image after our translation. What would the rule for this translation be? So if we started with all our values as x, y, and we wanted to find a rule to describe how they slid. Well, really you only need to go one at a time. So let's look at h. How does h move to h prime? Well, going left and right, we had to go 1, 2, 3, 4, 5 to the right. So 5 right. And then we had to go 1, 2, 3 up. So using that information, 5 to the right and 3 up, well, 5 to the right means we're increasing on our x value. So x plus 5. 3 up means we're increasing on our y value. So all the y values added 3. And that would be our rule then. And that'll cover it for our first video.